Back to the channel. So today we're solving this problem, minimum string length after removing substrings. So you're given a string consisting only of uppercase English letters, and then you want to apply some operations where you want to remove any occurrence of substring that it is AB or CD, right? And then knowing that we actually return integer because string is actually not it's immutable in Python, so you can actually like change or modify that string. But yeah, so this is the question, and then we want to return the minimum possible length after we remove all like the A, B, or C, D. So for example, we have A, B, F, C, A, C, D, B here, and then we can see that this A, B is definitely going to be removed, and then later on we see a C, D right here. After we remove the C, D, we're resulting in A, B, so that's why we want to remove all of them, right? So let's start the concept. When we see something that we want to remove and then we find something that happened before, it in like intuitively it should remind you of a stack actually, because whenever we have something put in here, right? Let's say there's a stack and then you put A at the bottom and then you put B. Whenever you see a B, right, you want to not putting B first. You want to look at the stack and then like, hey, it's my previous one at A. If it's A, then we want to pop this out, right? We want to pop A out. So then we go on and then we put F into it, right? The stack, we put F into it, and then we put C into it, and then we put A into it, something like that, right? So let's go through one example with this, and then we'll like visualize how the stack works, right? All right, so let's say we have a stack. I'll just use an array right here so it's easier, right? So we put A into it, and then when we say B, when we look at B right now, and then we're like, hey, actually the previous one's A, so we pop A out. So we pop A out, right? So we pop A out, and then we didn't put B in because this itself is an AB, right? So later on we move on to F. So we put F in. Oops. All right, it's okay. This is F. We put C in. It's fine, right? We put A in. It's fine. And then we put C in. It's still fine. Until this point, we look at this D, and then we're like, hey, the previous one is actually a C, right? So we want to pop C out, and then we're not also adding D into it, right? So now A is the latest one right here. And then we go on to B, and then we're like, hey, we have B. Is the previous one A? So we look at this. This is A in that. So we don't add B in, and then we also pop A out. So initially I thought we need a while loop, but now I think we can just go through this one time, right? We can just go through it like this. Because whenever we hit something, we pop them out, we pop the previous one out. So this, like, okay, like let's say we have C and D, right? So with C and D, when we hit D, we didn't add D in and we pop C out. So whenever you hit the next thing right here, you're like, hey, actually we can just look at the previous one on top of the stack, because that's not gonna be a case where, let's say you have C, C, D, D, right? When you pop these two out, D will just look at this C. If you have A right here and B right here, then this is gonna be pop out. So when you have D, this is not adding it, and B will point to the A and then pop this A out anyways. So you don't actually need a while loop. So let's just start coding it out and see how it is. So we can initialize the stack, and then for every character in S, that's what we're gonna do. And then there are only three cases. One case is you see yourself as if you see yourself as a B, right? And then the stack, there is a stack, and the stack, the top of the stack is A. That's the time you know that, hey, you want to pop this out, right? Or the other case is you self as a D. You self as a D. Oops. And there is a stack right there. And the top of the stack is equals to C. Then you also want to pop the stack out. So what's the third case? The third case is everything else, right? If you're not as B or you are B, but there's no stack, and all your previous one is not A, you want to append it into your stack, right? So you just want to append C into the stack. So at the end, what are we returning right here? We're actually just returning the possible length of the resulting string, right? So what that is the stack, right? Because we remove all the A, B, or C, D. So we just need to return the length of stack at the end. Right, cool. So as I said, this is a one-time pass. You only just need to go to the string one time. So this is just O of n for the runtime. And then the stack is the space complexity will also be of n, O of n. So imagine that you have something random like all B for like the constraint. So how long can the string be? Like 100, right? Then it's just gonna be all of 100 anyways, actually. So you just put everything into the stack. So it's interesting. This runtime is kind of like all of one anyways, but okay, cool. So this is the video of the day, and yeah, I'll see you in the next video.